Harsha, when we talk about the data science, there are a lot of different terms that are used in the market. For example, deep learning, LLMs, there's machine learning. So maybe you can break it down for the audience who are just starting out or who are at the early stage of their career. Like
data science is an umbrella,
okay,
right?
And you talked about the impact.
Yes.
What does that exactly mean?
Yeah, so impact, there's really two ways to assess impact, right, Sahil? One was always the technical approach,
okay,
which is what 99% of candidates do.
As a student,
yeah,
as someone who's just starting out, what does a good project should mean to them?
Yeah, so what I see a lot of resumes is generally people tend to use a Kaggle data set, build on a machine learning kind of model,
That's true.
And then say it's 95% accurate. That's my,
That's
project,
it.
like
Yeah.
put that as a bullet point. That is great for your learning, right? I am glad that you learned that.
Are there enough jobs in the field of data science?
Yeah, so if you asked me this question, Sahil, 10, 15 years ago, I would say it would be very hard because you need a master's, you need a PhD, you need to be extremely smart on research, you need to have a lot of kind of publications and stuff like that. But now it's not like that.
What can be a balanced resume as per you, like for a data science candidate? Thanks a lot, Harsha, for giving me your time and coming here for the discussion on data science. And it's a pleasure to host the conversation with you, man.
Yeah, no problem, Sal. Thanks for having me. Looking forward to what I can provide. I know we are co-workers, but it's going to be a fun one.
Awesome, Harsha. So I know a lot about you, but maybe you can
Yes.
introduce yourself to the audience. And I know I can assure the audience that I got the perfect candidate to talk about data science. But maybe you can introduce yourself to the audience.
Yeah, for sure. So hi everyone, my name's Harsha. I'm a senior data scientist here at RBC. I do work with Sahil. Unfortunately, we don't work on the same projects. But a bit about myself, Sahil, really. From my undergrad, I did study business technology management. I was the valedictorian in my class. And initially, when I started my career, I thought I'd be the best front-end developer, right? I thought I was going to go into software engineering until I figured out that I really like ambiguous problems. So that's when I tried out data science at RBC as an internship. And I've been working at RBC full-time ever since. The cool part with this is that I kind of got into data science before the hype and the AI, which we can get into. But ever since then, I've been at RBC. I've interviewed at least 100 candidates. I've done multiple talks for co-op and new grad students. I also did multiple panels with vice presidents and whatnot. So, I love these kind of talks, and I love helping out professionals, especially in the early careers. So I'm glad to be here today.
Awesome. Thanks a lot, Harsha.
Yeah, no problem.
So, Harsha, when we talk about the data science, there are a lot of different terms that are used in the market. For example, deep learning, LLMs, there's machine learning, and whatnot, right?
Yeah.
And NLP is one of them.
Yes.
So maybe you can break it down for the audience who are just starting out or who are at the early stage of their career, like what these terms are, how they fit under umbrella of data science, and anything that's more important or more should they prioritize more than anything else?
Yeah, no, it's exactly what you said, right? Data science is an umbrella, right? And if we take a look at the landscape, the best way I kind of describe it is it's similar to software engineering. So when someone asks you, what do you do for a living? And you say, I'm a software engineer. Generally, the next question is, what kind of software engineer?
Exactly.
And the answer is, I'm an iOS developer, I'm a web developer, I do backend, right? Or I'm in cybersecurity. One of those fields, and you know exactly what they do. 10 years ago, data science used to be a simple question. What do you do for a living? I'm a data scientist. That answers your question. But now if you ask someone, what do you do in data science? It's like, okay, what part of data science? Do you do NLP? Do you do deep learning? Do you do machine learning? So for me, for example, I'm very good at machine learning. That's my bread and butter. Similarly, I know people at the bank and our companies that they only work on NLP or let's say LLMs, right? So it really depends on what kind of data scientist you're kind of going for, kind of aiming for. But once again, you cannot be the one like master of all, right? It's kind of that jack of all, master of none kind of thing, right? So you want to be a master of one of them, but you also want to know all different areas. Similar to engineering, you have, let's say, an engineering leader. They probably have their career built on front-end development, but they probably know the entire career landscape for engineering.
Right. But is there any specific domain that the freshers or someone who is just starting out their career, they should be more focused on? You said go deep into one of the topics, right?
Yes.
What should they choose? From where should they start? Is there anything that exists like this?
Yeah, I would say machine learning is the foundational start to any data scientist, right? So nowadays we see a lot of AI. Let me dig into LLMs. Let me understand how they work. But really, 90% of problems at any large company are machine learning problems, right? Only 10% or 5% are actually LLM projects.
Okay.
What that means is the market demands more data scientists to know machine learning than they do for LLMs, right? Okay. But the way the market is shifting and what we're seeing in the, let's say, the job seekers is that they are focusing more on the LLM side, which is kind of where I feel like people should focus more on the machine learning, because at the end of the day, that's where 90% of problems are for large companies, but then also really for your personal understanding of the domain itself, right? And when we talk about machine learning, let's say we build a model and we deploy it at the bank. One of the questions is, how does a model work? Right? The big question with large language models is we don't know how it works, right? But with machine learning, like XGBoost or regression or any terms like clustering, we know how these models work, and we're able to explain it. So when you go to a business partner and say, hey, I built this XGBoost model, it has 92% AUC, great, what does that mean, right? And, or it could be like, why is that the reason? Why is it doing so well, but then our end business impact is not that good, right?
Exactly.
So you always want to understand how these models work. And the only way to do that is to understand these models at a foundational level, and this is where your statistical knowledge comes in, right? And when we talk about statistics, it's more so on, let's say, regression, L1, L2 penalties for XGBoost, whatnot, but then also on the hypothesis testing, right? You know, A/B testing sounds very basic, but it's also very important, right? And I feel like a lot of data science should start there. Understand these machine learning models, how they work, and then once you understand how they work, try to explain it to a friend. Right? You have another friend, let's say, that's learning data science. I know you have a lot, I have a lot. Let's say, you know, they'll be like, okay, Harsha, can you explain what XGBoost is? I can explain it to them. Okay, do you know what a hyperparameter is? Of course I do. I'll explain it to them. And then I can, in reverse, ask them a question. Can you explain to me what this hyperparameter means? Right? Why do we use that hyperparameter? How does it affect the model? How does it affect the results? Have that discussion between you and your friends, or even just set up a coffee chat with a real data scientist and be like, hey, I just want to expand kind of what I'm learning and kind of test me on these things, right?
Exactly.
Explain to them your knowledge of it, and they can correct you. Well, that's not exactly how I would explain it. I would kind of approach it in this way, right? So have that conversation, learn the foundational. I think that's where all data scientists should start off.
Awesome. I think you brought forward a very important point, that students, they are not focusing on traditional machine learning, or they are not even trying to answer the question that in data science what they should learn. Because I review a lot of resumes. The first thing I see on every resume, it's like, I know LLM. I have worked upon, let's say, the OpenAI stuff, and I've created this chatbot that is able to answer all the questions. It's a clone of ChatGPT, and I'm like, okay, but are the companies explicitly hiring for these kinds of role? And the answer is no, right? But then why are you writing these kinds of stuff on your resume? And this brings me to another important point, right? So whenever students, they are, let's say they are learning the machine learning models and everything, and you talked about the impact.
Yes.
What does that exactly mean?
Yeah, so impact, there's really two ways to assess impact, right, Sahil? One was always the technical approach, which is what 99% of candidates do. But that's just the first step of any modeling, right? So let's say you achieve a 90% model. What does that really mean for the business? Right? You know, one example I can give you is our RBC, we have a product called Know Me Insights, which it's public, so feel free to download the app, try it out. Essentially what the app does is it predicts your upcoming bill payments. So let's say I have a mortgage payment due next Friday for $2,000. Now, from a technical approach, how would you assess whether this is accurate or not? One way is just to wait till next Friday and see if it's actually true or not. If I'm predicting that it's going to be $2,000 in bill payment, and next Friday it's actually true, that's $2,000, great, that's accurate. Do this across, let's say, 100,000 clients, and let's say you achieve a 95% accuracy, that's great. You go to the business and tell them, hey, our model is 95% accurate. They couldn't care less. What does it mean for the business? Right? And this is where you kind of go into the quantitative approach and kind of build an analytical mindset in terms of business impact, right? So the other approach to assessing this model is, what is our end goal? Our end goal is not to create a 95% accuracy. Our end goal is to kind of develop and improve that client experience or client behavior. And here what we're seeing is a $2,000 bill payment, the goal is for you not to go into overdraft. So for the goal is to at least have $2,000 in your bank account so you don't go into overdraft. So from a client behavior is, if on average I have $2,000 bill payment, did I make another kind of deposit into the bank account to prevent me from going to overdraft? That is one metric, right? And you kind of look at the clients holistically across the entire bank, and you can see that improve in terms of metrics. The other approach is really the core business. At a bank, how do we make money? It's very simple. More money in, we kind of lend that money out, and that's how we make money. right? So deposits is what really drives banks. So are we bringing in more money? If I have $2,000, would I just put in an extra $1,000 every month into the bank just to keep peace of mind for me, right? If I'm doing that, it's peace of mind for me. For end of the day, for the bank, it's more revenue, right? So when you have a control group and test group, you can kind of really see these metrics going up, and that is what business impact is about, right? Create that machine learning model, put it into, let's say, any data set or whatever you have, pre-process it, build them all out, and then get that technical, I guess, impact, right? You need to understand if it's 95% accurate. That is your job as a data scientist, to make sure the model is technically accurate, right? But then the last part, which a lot of people skimp out on, is kind of the business impact. Build that framework, showcase that it does create impact, and that's what a true data scientist is.
Okay, awesome. So you talked about the business impact, right? And you said, like, let's say that a fresher or someone who's just starting out their career, they have focused upon the basic machine learning part. They know what are different kinds of model, how they work inside out and everything. And now they know that, okay, I need to create a project that drives some business impact, or it's solving a problem, right? But how should they come up with a business problem? Because if someone is not in the industry, they won't get a chance to work on the tool like Nomi or anything that's exactly solving the real life problem. As a student, as someone who's just starting out, what does a good project should mean to them?
Yeah, so what I see a lot of resumes is generally people tend to use a Kaggle data set, build on a machine learning kind of model, and then say it's 95% accurate. That's my project. Put that as a bullet point. That is great for your learning, right? I am glad that you learned that, but from an impact perspective, from an analytical thinking mindset, you did not really encompass the end-to-end machine learning pipeline. And that is one project I always look for, is a full end-to-end project, right? End-to-end really means everything from sourcing that data. So use Kaggle for learning, but for sourcing data, kind of think about it yourself, where you're going to get that data. And even before you get the data, think about what the business problem is. Generally, what students tend to do is pick a data science model and then put a problem into it. It should be the other way around. Get the problem and then think of a data science solution that's going to help solve that, right? One example I can give you is I did a couple years ago. I'm not sure if we discussed this before in our previous discussions, but it's always about credit cards. I'm a big credit card enthusiast. I love collecting points. I make sure I get the best bang for my buck and make sure I use the correct credit card for credit expenditure, right? So for me, I wanted to know, well, I know so much about credit cards, but can a model really understand that as well? So I kind of aggregate all the data from different banks and financial institutions in terms of what credit cards they offer, interest rates, travel, or is it points, is it cashback, all that data. And then I kind of created a data set. It's not big. It's only a few hundred rows. I built that data set and said, hey, as an input, I'm a young student. I spend $500 on food and I spend another $500 on entertainment. What is the best credit card for me? How do I validate that? Well, I know my preferences. I'll be like, based on the input I gave, I'd probably want this credit card. And I check the model results. And if it does say like, hey, this is a good credit card, then yeah, the model is working effectively. I built that project end to end, right?
I think the point is to be more aware of about your problems, the problems around yours, around yourself, among your family, friends, and everything, right? So whatever problem you're trying to solve, just look at that problem and try to see how machine learning can help us.
And it doesn't have to change the world, right? You can create another problem to predict, let's say, what the score is going to be in the next soccer match.
Awesome. So let's say so far we have just created a good machine learning project and we have thorough understanding of how different models work, right? But then comes the part where we actually need to get a job. So if I talk about the Canadian industry, are there enough jobs in the field of data science? And is this industry just for the experienced people, the mid-senior to the senior level roles, or it's also someone who is just graduating out, they can target these kinds of roles?
So if you asked me this question 10, 15 years ago, I would say it would be very hard because you need a master's, you need a PhD, you need to be extremely smart on research, you need to have a lot of kind of publications and stuff like that. But now it's not like that. Because companies realize that the value from these models is not just the modeling, and sure, there are a lot of technical folks out there, but it's the impact that a basic model can create, right? A simple linear regression model, a simple XGBoost model can create multi-million dollars in revenue for a bank or for any large company. But it also, you need someone that's really good at communication, right? I feel like that is very estimated, the value of communication. And this goes back tying into the business impact and whatnot, right? And to answer your question about the Canadian market, I will be honest, it is tough. right? We are seeing a lot of folks in tech trying to get into data science, get into engineering, but we don't have enough jobs available. And that is due to, I guess, the layoffs and the situation in general. But one thing I will say is the data science field is expanding.
Okay.
Right. So in the beginning, you asked me about what all those different lines of subjects are. Those topics or those niche areas are going to expand.
Okay.
Right. We're going to get into specific data scientists for bias. Right. Data science that only focuses on bias research, and then also privacy. How do we make sure that we're not going into, private information that it's against government regulations? There's going to be data scientists for that.
Okay.
Right. So we are going to expand the data science field, but in general, right now I feel like 90% are targeting LLMs. Right, so I would say start off learning your machine learning foundationals. That will open your market to, let's say, qualify for 90% of roles out there.
Okay.
And then, if you're lucky or if you're really interested in LLMs, do some more research on it. Right, a lot of people, LLM is more than just prompt engineering. Right, understanding how it works is not enough or equivalent to why it works. Right, you need to know why LLMs work the way they do. Right, and that is when you get into more research, understand the theory behind it. And of course, there are black box models, but if you can understand it better than the average person, you have an advantage.
Right. Awesome, man.
Yeah.
So you just talked about LLM and different kinds of projects, right? So I've also told you that when I'm reviewing resumes, the first thing I notice is the word LLM or OpenAI or these kinds of buzzwords that you hear around a lot, right?
Right.
So if, let's say, we are talking about the resume, what can be a balanced resume as per you, like for a data science candidate?
So I would say you need at least one foundational machine learning project. That is going to be the project that you showcase as this field, right? You did your research, you kind of entered it, you know the basics, you know the foundationals. And then the next project can usually be anything that you're interested in, right? Whether it's an LLM specific, where it's NLP, you do some deep learning, any image classification. Those kind of things are all projects you're interested in.
Okay.
Right. I know a lot of folks are actually interested in image classification, and they apply to Tesla because they have a lot of data set, and it has to tie in with the job. Right. If you are doing a project or building machine learning models that the company has nothing to do with, then it's going to be harder for you. Right. The machine learning projects usually kind of build your foundations, but the additional supplemental projects you put has to be related to that industry. Right?
Okay.
And it's easier to build, I would say, multiple machine learning models, let's say another binary classification or whatnot. So the credit card example I gave you is very related to RBC, right? That kind of helped me get into RBC as well. But I wouldn't build an image classification on, let's say, a data set about cars, or let's say streets or geography or something like that. That would have nothing to do with a financial institution.
Okay.
Right? So also, when you're building these models, pick it towards or related to your industry.
Okay.
Right? And I know, Sahil, you're going to ask me, well, Harsha, when people apply, they apply to multiple industries.
Exactly.
Right? So that's why you need to have multiple projects. Right? And what I mean is one project could be about financial institution, about credit cards and whatnot. Maybe another project could be about you built this app or your friend built an app and you kind of improve the user experience.
Yeah.
Let's say you built an A/B testing framework around it. How do you improve the user experience? Did you onboard more users, right?
Okay.
So those are different kind of ways to go about it and kind of thinking about the landscape as a whole.
Okay, awesome, Harsha. Yeah. And if I talk about your interviewing experience, I know you have interviewed over 100 candidates, and you're going to interview a lot more in the future, right? So is there any sort of pattern that you have noticed, the top mistakes that students are committing, or you feel like, oh damn, the students are missing this very simple thing that they should have either in their resume or in their personality, maybe in their introduction, maybe in their projects. What are those common mistakes that students are committing?
So the number one mistake I would say for data science is students and candidates tend to oversell themselves.
Okay.
And what I mean by that is if I look at a resume and it has every buzzword in the data science dictionary, so what you mentioned beginning, deep learning, LLM, AI, every single thing, I know you're a jack of all and a master of none. Right? I know that you know a little bit of every area. I'm not saying you don't have knowledge, but I will know for a fact that you know all of it at a very broad level that I can Google as well. But you don't have deep expertise in any single area, right? And that is the first mistake that catches, or we see straight off the bat, that they kind of pitch in all their kind of tools and technologies. And the way I'd compare it is a software engineer. When you look at a software engineer, you would know if they're iOS developer or front-end developer by looking at a resume. But if they have every single front-end framework, every single iOS kind of tool they use, all the back-end, I guess, APIs, then you know they're kind of all over the place.
They're just experimenting with that.
Exactly, they're all over the place. So really pick a niche down on one area of data science. And the second aspect really that I see is you're not quantifying your impact, right? And what I mean by that is we did talk about 95% accuracy versus business impact, kind of quantifying that. And I do understand it's hard in the beginning, but you are solving a problem, right? That is the purpose of data science, is you are solving a business problem. That business problem for these products are defined by you. Right. So if you are not able to convey the impact, then that is a problem itself, right? And when you come to the real job, that is what is expected of you. Because I can teach you how to build an XGBoost model, Sahil, and then you can build it for and deploy it. But I cannot teach you how you can communicate that to the business team.
Exactly.
That is something that's going to require knowledge from you and experience, right? And that is something that we do look for in resumes is, are you able to communicate, right? A good portion of data science is actually communication. That's both written and oral, right? And the way you kind of frame your sentences, and you have to build slide decks, you have to present, right? So that is a very important aspect as well.
Awesome.
Yeah.
Thanks a lot, Harsha. I think I can talk forever for data science, and I know you are so full of knowledge that the conversation might never end, right? Yeah. But I think we need to end up today's video, and it was really great insight. I have learned a lot. Like we have talked so much about data science, like apart from this video, but every time I talk to you, I learn something new. It's always a new insight or a new direction in the terms of data science that I always get from your side. Yeah. And thanks a lot for sharing this valuable information with the audience. And
no problem, Sal. And thanks for having me. This is a great podcast. I do want to acknowledge that what you're doing for students is great.
Thank you so much.
I also want to let people know that the job market is tough, but there is light at the end of the tunnel. And if you keep at it, data science is an evolving field. So more opportunities will always open up. So keep your head up, and good luck to everyone.
Awesome. Thanks a lot for watching.
Thanks, everyone.